Hey everyone, welcome to today's Explainer. If you're a cloud architect, a DBA, or just living in the trenches of IT operations, you are going to want to hear this. Today, we're breaking down exactly how to shift your infrastructure away from legacy polling and move towards real-time OCI database backup monitoring. You know that feeling of constantly chasing down backup statuses across a massive fleet of databases? Yeah, it's exhausting. Well, we're taking concepts from a fantastic technical deep dive and building a clear visual roadmap so you can build the ultimate event-driven dashboard. So let's get right into it. Okay, here is our game plan for today. We'll start with Section 1, the polling problem. Then, we'll map out the event-driven architecture flow, walk through the step-by-step implementation, take a look at the ultimate backup dashboard, and wrap it all up with key operational takeaways. Starting with Section 1, the polling problem, or as I like to think of it, the limitations of delayed operational blind spots. To really appreciate the new event-driven architecture we're building today, we kind of have to face the music about how things used to be done. In older setups, teams leaned heavily on multi-tier REST API calls just to gather basic metrics and metadata. But I really want you to ask yourself, is your database backup data already stale? Imagine an auditor taps you on the shoulder right now, or a critical alert fires off, and you need your backup compliance report this exact second. If your setup relies on periodic polling, running a script every 15 or 30 minutes to check the Oracle Cloud API, your data is already behind. And let's be real, in an enterprise environment, a lot can go sideways in 15 minutes. Those delayed blind spots, that is exactly what keeps ops teams awake at night. This right here really hits the nail on the head when it comes to the paradigm shift we're talking about. On the left side, you've got polling. This is basically the infrastructure equivalent of a kid in the backseat constantly asking, "Are we there yet? Are we there yet?" You're just burning compute cycles and API limits, constantly asking the system for an update. But look at the right side. Event-driven. This is the sweet spot. We're talking immediate push notifications. The literal millisecond a backup completes, fails, or changes state, the database pushes that exact payload right to you. It's incredibly efficient, and best of all, it is truly real-time. Moving right along to Section 2, event-driven architecture flow. Basically, the data relay race from database to dashboard. Let's reverse engineer this component by component so you can see exactly how the data flows through OCI. Think of this whole setup as a highly efficient relay race, where the baton is your backup event data. It kicks off with the OCI database service. The second a backup finishes, it generates a standardized CNCF formatted payload. Boom. Instantly, the OCI event service grabs it based on the rules we've set. But here's the really clever part. Instead of launching it straight to the dashboard, it passes the baton to OCI streaming. This acts as a reliable buffer, which means if there's a hiccup anywhere downstream, you are never going to lose your audit data. From there, the Service Connector Hub automatically grabs that buffered data and routes it straight into OCI Log Analytics, which parses it out and feeds our dashboards. Honestly, it's just a beautiful, seamless, serverless flow. All right, Section 3, step-by-step implementation. Let's bridge the gap from architecture to reality. So, the architecture looks amazing on paper, but how do we actually wire the whole thing up in the console? Well, in these first 3 steps, we're basically just laying the foundation to capture those events securely. First up, we spin up our OCI streaming stream. Remember, this is our shock absorber. It holds on to the data. Step 2 is where we tell OCI what we actually care about. We create an events rule, specifically filtering for the database service and targeting event types like backup database end or start. And step 3 is absolutely crucial. We import a custom parser into Log Analytics. See, because OCI events come in a very specific JSON structure, this parser is what tells our analytics engine exactly how to extract the database name, the status, and those all-important timestamps. By step 4, we're bringing the whole shebang together. The Service Connector Hub is totally the unsung hero here. It automatically wires our stream right into Log Analytics. And get this, you don't have to write a single line of integration code. Pretty great, right? Once that connector is humming along, step 5 is just proving that it actually works. You trigger a manual database backup, and you can watch the logs pop up instantly in the Log Explorer. And once you've got that data flowing, you're completely ready for step 6, which is the ultimate prize, creating the dashboard widgets themselves. Which brings us to Section 4, the ultimate backup dashboard, visualizing database health and compliance in real time. So now, we're transforming those raw JSON events we just routed into highly actionable operational insights. Let's look at what you can actually build. First up, a time series bar chart. By graphing these backup events over time and grouping them by backup type, incremental, full, or archive logs, you could immediately spot systemic anomalies. Think about it. If you normally see a massive spike in incremental backups at 2 a.m., and suddenly, tonight, that graph is totally flat, you know instantly that a scheduling policy might be broken, long before any individual database even reports a failure. Next up, we've got the classic status breakdown. This simple percentage view showing success, failed, and in progress is exactly what you want up on a massive screen right in the middle of your ops center. It gives you an instant visual pulse check on your entire fleet's backup health. If that failed slice grows beyond just a tiny little sliver, your DBAs know immediately that it's time to dig in. It's really all about drastically reducing the time it takes to recognize a problem. But listen, dashboards aren't just for 30,000-foot overviews. When you need to get granular, like for compliance tracking or a real deep dive troubleshooting session, you can build a structured tabular report right there in Log Analytics. Notice how this perfectly organizes everything by database, backup type, status, and time. So when an auditor asks for hard proof that a specific critical database was backed up successfully over the weekend, boom, this is the exact widget that gives you the answer in about 3 seconds flat. And finally, Section 5, Key Operational Takeaways, the real benefits of an event-driven evolution. Let's zoom out for a second and look at the big picture of why taking the time to complete this specific OCI setup matters so much for your team and, really, your organization's overall data posture. When you embrace this event-driven architecture, the benefits are immediate and they seriously compound. First, you get unified monitoring. No more hopping between 5 different screens for block volumes versus databases. It is all in one single pane of glass. Second, streamlined compliance. Your audit reporting turns into a simple dashboard export instead of a multi-day data gathering nightmare. Third, you gain actionable insights, letting you finally visualize trends by region or compartment. And finally, proactive alerting. Because these are real-time events, you can trigger automated runbooks the exact second a failure event is captured. By combining this event-driven approach with the metadata collection strategies you probably already have running, you finally achieve complete automated visibility into your entire backup infrastructure. Thanks so much for joining me on this explainer today. I highly encourage you to try wiring this up in your own OCI tenancy. To wrap things up, I want to leave you with a fundamental shift in mindset. Why waste precious compute cycles, not to mention your own human capital, constantly checking up on your systems, when you can empower your architecture to report its status directly to you in real time? So here is the big question. Are you going to keep asking your databases if they're backed up, or are you going to let them tell you?